Hello and welcome to lesson 2.1, polynomial functions. So today we're going to look at some various different polynomial functions, the equations, the graphs, so forth. So right here we have an example of a graph being shown here, and due to the fact that it has this shape and it looks like it has a double root right here, as in it just touches the x-axis, and two single roots, my best guess is this is a quartic function. You could probably argue that it could be a hexic function or a degree 6 function, but specifically this looks like it's just degree 4, so we're going to go with the degree 4 option. Okay, so since we know it is a quartic function, we're going to start out by writing the function f of x. Because I know my factors, I can write down the factors, but I don't know the stretch or compression factor. So I'm going to write down a, because I don't know what that value might be. But I do know one factor could be x plus 4, because it goes through the 0 at x equal to negative 4. Also has x minus 3 as a factor, because it goes through x equal to 3, and also goes through that, or touches x equal to negative 2. So that should be x plus 2, and because it's a double root, we call it squared. So now we just take any point that's actually on this function that we can specifically divide. So in this case, we have a point 0, 6. We substitute that in for f of x and x. And we can actually work out the value that we get here. So this is 6, this is 4, negative 3, also 4. That value of a is being multiplied by negative 48. And if we divide by both sides by negative 48, I get an a value of negative 1 over 8. So that actually tells us that our function has a specific equation in factor form of negative 1 over 8 times x plus 4 times x minus 3 times x plus 2 squared. Now, if you've forgotten what a triple root looks like, a triple root kind of like hovers at the x-axis for a short period of time. So it does still cross through, it just stops momentarily there and then continues on. You can review your notes from grade 11 to verify those. Okay, so what else we need to review? Well, we also need to review how to actually divide. We're going to practice synthetic division later, but right now, because x squared plus 1 is quadratic, which we call our divisor, so we have a quadratic divisor, we may need to use long division. We can only use synthetic division if it is not quadratic. So we should set this up. We start out by writing the dividend, which is 3x to the 4 plus 2x cubed minus 2x squared plus 2x minus 1. We put our division sign. We put our divisor over to the side here, x squared. I suggest if you don't have a term showing, actually write a 0 in place of its coefficient. So in this case, x squared plus 1 changes to x squared plus 0x plus 1. And now we go through our division. So let me show you how we work out our division. Focus on the 3x to the exponent 4 and the x squared. You want the x squared to multiply by something, to give you 3x to the 4. And that is 3x squared. So you put the 3x squared above the negative 2x squared, because that's the same, let's say, unit system. You take 3x squared, you multiply by all of x squared, 0x, and plus 1. This answer you're going to subtract from the previous statement. This will give you 2x cubed minus 5x squared. So in order to continue on, you need to have 3 terms in your expression. So this must be a 2x here. And again, you start all over. So you look at the x squared, you look at the 2x cubed, and you think to yourself, what must multiply to x squared to give me 2x cubed? That's 2x. So 2x times x squared is 2x cubed. 2x times 0x is 0x squared. 2x times 1 is 2x. Again, subtract. And again, do it again. What you get is a remainder. As long as the remainder is smaller in degree than the original function, quotient, or, my apologies, then the divisor, then you should be okay. This part up here is called your quotient. So what you can do is you can write a division statement. Division statement takes your original dividend, which is 3x to the 4 plus 2x cubed minus 2x squared plus 2x minus 1, and it equates it to the divisor times the quotient plus the remainder. So this is how you go about long division and writing a division statement. So let's review synthetic division, and while we're doing that, we'll also review factor theorem and remainder theorem. So in order to factor something, you have to find a value where if you substitute a value in for x, you're going to get equal to 0. Well, to do that, you have to choose factors that multiply first to the value of 6. So things like plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. These are values that would multiply to be 6. If these values don't work in place of x and give you a value of 0 or find zeros, then you are going to have to go to looking at a first constant and taking those multiples of 6 and divide by multiples of 2 to see which ones might work. So the ones that might work, if any of the factors of 6 don't work, might be plus or minus a half and plus or minus 3 over 2. The other ones, when you divide by 2, will stay a number that you might already know. So let's find out. So let's calculate f at 6, just as a guess here. And you find it's equal to 264. So what that means is, if you take f of x and divide it by x minus 6, your remainder that you come out with is 264. This is what we call the remainder theorem. Now this is not what we want. So pick another number. We're going to try the value 3. Now it's just a random guess. There's no exact way to do this, just some random choices. And we see f at 3 equals 0. So that means x minus 3 is a factor of the function f of x. Okay, so now that we have that, we're going to set up synthetic division. Synthetic division, again, only works for linear expressions. So how you set it up, you put the 3 on the outside, which is the 0 of your factor that you found. You're just going to take the coefficients of 2x cubed minus 3x squared minus 11x plus 6. And you write it down like this. So now, you just drop the 2 here. You take 2 times 3. You put it here, which is 6. Then you add the 6 minus the 3. You get 3. 3 times 3 is 9. Put it here. Negative 11 plus 9 is negative 2. 3 times negative 2 is negative 6. And 0. So here you see the remainder is again 0, which is exactly what you want. So synthetic division was created because division and subtraction is sometimes a little bit more challenging to deal with. So they dealt with the opposites, looking at addition and multiplication, which is just the operations that we just did here. So what this means is our function f of x is now equal to x minus 3, which is the factor that you just found. And the coefficients you just found are of 2x squared plus 3x minus 2. From there, you can factor using your methods from grade 10, or you can apply your factor theorem again, which is another option. Since this is easier to factor, I'm just going to write 2x minus 1 and x plus 2. And there we go. We have fully factored this expression. So let's try that again with a more challenging function. So with this one, you could try factors of negative 8. Unfortunately, none of the factors of negative 8 will work. So 1, plus or minus 1, plus or minus 2, plus or minus 4, or plus or minus 8 doesn't work. The only factor that will work here turns out to be 2 over 3. And again, you can check this for yourself if you'd like to make sure. So again, I'm going to use synthetic division here. My 0 is 2/3. Leading coefficients are 27, 0, 0, and negative 8. So 27 times 2/3 is 18. 18 plus 0 is 18. 2/3 of 18 is 12. That's 12. 2/3 of 12 is 8, so that's 0. So what this means is our function, f of x, is equal to x minus 2/3. Remember, the 2/3 is the part from our expression. And our leading coefficients are 27x squared plus 18x plus 12. Now, we don't typically write it this way, so what we're going to do is we're going to borrow a value of 3. As you can see, that's common between all these expressions, and multiply it to our first value, our first factor. So we get 3x minus 2, and we get 9x squared plus 6x plus 4. Well, here you might actually recognize a pattern here. You might realize that you have what is called a difference of cubes. So if you can write a cubed minus b cubed, or your expression in terms of an a and a b that is cubed, it can factor into a minus b times a squared plus ab plus b squared. If you don't recognize this pattern, of course, again, you could just go about working this out. So you can see the 6x is actually a combination of the 3x times the 2. And there's also a sum of cubes pattern. Which has a similar look to it. So a cubed plus b cubed equals a plus b times a squared minus ab plus b squared. And there we go. So we have reviewed our skills with factoring, we've reviewed our skills with actually what a polynomial function might look like and how to work out its equation, and also long division. And thus concludes this lesson.